Edexcel Core Pure First Order Differential Equations, Finding Integrating Factors. We've previously seen that we need the equation to have the form dy by dx plus py equals q, where p is a function of x and q is a function of x as well. So we need to have it in this form in order to start thinking about integrating factors. So our aim is to make the left hand side into a perfect derivative of a product, and we can do so by multiplying both sides of the differential equation by a special function of x, and this special function of x is called the integrating factor. So if I call the integrating factor f of x just for convenience at the moment, what we're aiming to do is, if I multiply both sides by f of x, is to get it in the form f of x times dy by dx plus p times f of x y equals q f of x. And it's the left hand side I'm particularly interested in. If we look carefully at this left hand side, then that second bracket is the derivative of f of x, and therefore the left hand side is a perfect derivative of a product, and the left hand side can be written as the derivative with respect to x of something called y f of x. So that would be leave f of x, differentiate y, plus differentiate f of x, leave y. So how do we get this to happen? What do we need to make the f of x produce this perfect derivative of a product? And the thing we need in order to achieve that is that f of x needs to be e to the integral of p dx, and that is the rule that you're going to use to find your IF, your integrating factor. That's how you're going to find it. The integrating factor is e to the integral of p dx. If you want a more formal proof of how this works, then you will find it in a textbook or on the internet. So the integrating factor that we're looking for here, I've called it f of x, and it is to create this perfect derivative of a product on the left hand side. And in order for that second bracket to be the derivative of f of x, we would need f of x to be equal to e to the integral of p dx, and that is how we find integrating factors. So let's put it into action with this example. We want to solve the first order differential equation dy by dx plus 1 over xy equals 4x squared. Notice we have the form dy by dx plus p of x y equals q of x. Everything is in the right form, which means that p of x, this function of x, p of x, is the 1 over x. So to get my integrating factor, the integrating factor is going to be e to the integral of this function of x, p of x, dx, which is e to the ln x. Notice you do not need to put a constant in this little integral. It is purely there to find this clever integrating factor. E to the ln x is x, so we're now going to multiply both sides by x in the original differential equation to get x dy by dx plus 1 times y equals 4x cubed. And now we can see again that that is the perfect derivative of a product. Indeed, it is the derivative with respect to x of the product x, y equals 4x cubed. Integrating both sides with respect to x, so the left hand side becomes xy. Integrate 4x cubed with respect to x becomes x to the 4. Don't forget the plus c, the constant of integration in this case, and therefore y is x cubed plus c over x is our general solution as we saw previously. So the key thing in these questions is to make sure you've got the correct form. dy by dx, make sure you've got a plus sign, that you've got some function of x, that's the p of x, y equals, and whatever's on the right hand side is q of x. Watch out for that plus sign. So here we can have a good look at it. Although we've got the plus sign, but on closer inspection we can see we haven't got 1 dy by dx. So the first thing we've got to do here is to divide through by cos x. So that'll give us 1 dy by dx plus, it's a good idea to keep p of x in its own little bracket. So this will become 2 tan x times y, and don't forget to divide both sides by cos x to leave cos squared x. Now we've got it in the right form, dy by dx plus p of xy equals q of x. Now we can start to pick out the integrating factor, which will be e to the integral of this function p of x, which in this question is 2 tan x dx. And if we rewrite that as e, and the integral of 2 tan x is 2 ln sec x. Using laws of indices and log laws, we can tidy this up. So e to the ln sec squared x using the power law, and now we can simplify it right down to sec squared x, and that is the integrating factor we need in this particular question. So make sure you've got the correct form. So here the vital step was to divide both sides by the cos x. We need 1 dy by dx in the question, and check you've got the plus sign. That means that this was p of x, and that is how we find the integrating factor, e to the integral of 2 tan x dx. So now we've got the integrating factor, there it is, sec squared x. I'm now going to multiply both sides by sec squared x to see what we get. So sec squared, I'll put it in brackets to make it a bit clearer, sec squared x dy by dx plus, and if you multiply 2 tan x by sec squared x, then we can think of it as 2 sec x times sec x tan x, and you'll see why it's helpful to write it like that in a moment, times y, and don't forget to multiply the other side by sec squared x. Should always check that you do have a derivative of a perfect product, and we have here, and the way to check is if we differentiate sec squared x, do we get that second bracket? And we do. If you differentiate sec squared x, you get 2 sec x times the derivative of sec x, which is why I've written it in that form. So the left hand side can now be written as the derivative with respect to x of y sec squared x. Try not to put the y after the, particularly a trig function like sec squared x, try and put the y in front of it, it's easier to read, much clearer, equals, and notice the right hand side before we integrate is simply 1. Sec squared is 1 over cos squared, so we've got 1. So now if we integrate both sides with respect to x, the left hand side becomes y sec squared x. Integrate 1 with respect to x is just x. Don't forget the constant of integration. And if I divide by sec squared x, we get y equals x plus c. And if I'm dividing by sec squared x, it's the same as multiplying by cos squared x. And there is my general solution. So the important thing here is to get it in an appropriate form. Once you've got your integrating factor, just check that the derivative of that sec squared x is indeed 2 sec x times sec x tan x. So just have a quick check and make sure you've got the plus sign, everything's in place before you attempt to write it as the derivative of a product. So the things to look out for in summary: make sure you've got the correct form of the differential equation. It must be dy by dx plus a function p of x times y equals a function q of x on the other side. Once you have identified p of x, then find your integrating factor and multiply both sides by that integrating factor. Double check that you are happy that the left hand side is the derivative of a product, and then you can write it as the derivative with respect to x of f of x times y, and then you are ready to integrate both sides with respect to x. Notice when you do integrate both sides with respect to x, the left hand side should always be y times your integrating factor f of x. So there's another thing to look out for in the process. That should give us an integral on the right hand side, which we are able to do using appropriate integration techniques. So that brings us to the end of this section on first order differential equations.